Okay, so today's video is going to be showing how to stress test the I/O on nanos using this tool called FIO, short for Flexible I/O Tester. Um, this is more useful when you're testing the back end of the driver, but you can also kind of see differences on the front end as well. And so it gives you a more of a measuring stick to kind of see what's going on. So how do you use this in nanos? Well, first you want to clone this repo because we're going to make a small little change. We're going to go into FIO, and so there's no changes in here, but what we do want to do is make a change when configuring it. So what we're gonna do is this configure disable shared memory. And you want to build that with that because Nanos doesn't actually use this shared memory apparatus. Most shared memory is used when you have one process talking to another process, and we don't have that in the Nanos, and so that's why we disable it. And then, it's just your usual make install, right? So we get that. And then the other change that you need to make is in Nanos itself. So there's two calls that FIO makes that we don't even have a stub for. And that is this get and set priority. So if you open up source Unix syscall, right? And it's going to be in this function called register file syscalls. So pass this little ifdef, and I just put them at the bottom because it was easy to put. And then you can do your normal make on nanos to kind of make a custom build for this. So once you have that, you can actually run in this. And if we look at our config JSON, I gave it a base volume size of a gig. You're gonna have to set something for this simply because the whole point of running the tool is to write a bunch of files to disk as fast as it can. We're gonna give it a file of test.fio, which is the actual FIO config, and then the args, so we can pop open this config and we can kind of see. Basically give the name, say it's going to be rammed right, block size of 4K, number of jobs, file 512, and then the IO engine, IO depth. So it's pretty basic. And then what we can do is go ahead and run it with ops. Now, typically I would suggest maybe running this in the cloud, just so you have like apples to apples comparison and you don't have to screw with any weird twiddling that you might have to do locally. It can kind of throw off your test, because otherwise if you're going to try to compare this, you're going to want a Linux guest that's using the exact same parameters, and so that might be a little bit more difficult to do. But at the same time, if you do it in the cloud, then I wouldn't direct it to serial because that's going to eat up all your performance and it's going to skew your results quite a bit. So you would want to save it to a file. So there's kind of this is one of these things that you're probably not going to do unless you're hacking on Nanos itself anyways. It's not even like, it's not like running AB or something where it's a very quick and easy dirty test. It's, this is typically for people who actually want to improve the underlying source. Anyways, so this is how we're running it. Pretty typical. I'm giving it 2 threads, SP2 here, mainly because we set 4 on the config. So we pop it open, and it spins up. It does its thing, and like I said, it's gonna write this, and then it's gonna give us a bunch of output as soon as it's done, which it just did. And so that's our results. And so what you would do when you're comparing to Linux is you basically do the same thing under the exact same commands. And just to kind of show you what that would really look at like is if you do the show debug -v, it'll show you the QEMU output that actually is getting ran. I can kill this window now. I'll show you the QEMU output, and so that's how you can kind of replicate with Linux there. All right, so this was a very short, quick little video. Just wanted to show you what was going on, and till next time, catch you later.